Hello, welcome to the Year 8 Scheme 1 Shape Revision Notes. Okay, so let's jump right in. So first up is translations, okay? So the first two questions, but they're going to be translating shapes following basic instructions, and then for parts C, D, and E, we're going to be using column vectors, okay? So for the first two questions, we're asked to move shape A 7 units down and label the image B, okay? So here is shape A, and we're looking to move it 7 units down, okay? So what I'm going to do is I'm going to focus on this bottom left corner, and I'm going to move it down 7 units. So 1, 2, 3, 4, 5, 6, 7. So this is where my bottom left corner is going to be. Now you can either do this for all 4 corners, or you could see where the next corner is, or the next point of the shape is, relative to this initial point. Okay, so I can see that the bottom right corner of the shape is 2 units across. So what I can do is this point I've moved 7 down. If I go 2 points across, I've now moved the bottom right corner of the shape. Look back at the shape now. The top right corner is 3 units away from the bottom right. So for this translated point down here, I'm going to go up 3. 1, 2, 3. So that's my top right corner. And then the top left corner of the original shape, I can see that's 2 units to the left. So same again, 1, 2. And there you go. This is now shape A that has been translated down 7 units, okay? And we're going to label this shape B, okay? So first one, job done. Now, for question B now, we're being asked to move shape A again, 5 units right and 2 units up, okay? So let's go to the dots again on this one. So we're going to do shape A again, but this time, because I'm going to start moving to the right, I'm going to focus on the bottom right corner of the shape, okay? So first of all, I'm going to do 5 units right. So 1, 2, 3, 4, 5. I'm going to put a little cross there just as a holding position, and then 2 units up. Okay, so 2 up from this cross, 1, 2. So this is now the location of the bottom right corner of shape A. Again, to get the bottom left is 2 units across, 1, 2. So that's my bottom left corner. Now the top right corner is 3 units up, 1, 2, 3. And the top left corner is 2 units across from the top right. So 1, 2. Okay, and if I draw in this shape now, and we were asked to label this image C. Okay, so question A and B all done and dusted. Okay, good stuff. I'm going to change the pen color for the next questions. Okay, so now for the next 3 questions, we're being asked to translate shapes using column vectors. Okay, and basically a column vector, if you may well remember from the lesson, it's where we have 2 numbers on top of each other in a big bracket, okay? Now the number on the top tells us whether we go to the left or whether we go to the right, okay? If it's positive, we go to the right, and if it's negative, we go to the left, okay? And the bottom number tells us whether we go up or down, okay? If it's positive, we go up, and if it's negative, we go down. Okay, so for example, a column vector, the first column vector here, we've got -3 and 0. Okay, so this is the same as, because it's -3 and it's the top number, that means it's asking us to go to the left 3 units. So left 3, and the bottom one is up or down, but it's 0, and then it's just up 0. Let's just call it up 0. Okay, so for the first one, all we're going to do is move our shape left 3 times, and we're not going to move it up at all. Okay, so for question C, translate shape Z using the column vector -3, 0. Okay, so here's shape Z, it's the triangle over here. I'm going to focus on this corner of the triangle, the bottom left corner. Okay, and I'm going to translate this 3 units to the left. 1, 2, 3. Okay, job done. So where is bottom right corner relative to that bottom left corner? Well, it's only 2 units across. So I'm going to go 2 units to the right, sorry. So I'm going to draw a point 2 units to the right. Now this was my original bottom right corner. Now how high is the top right corner of this triangle relative to the bottom right? Well, it's 3 units up. So from this translated point, I'm going to go 1, 2, 3, draw him in, and then I can complete the triangle. And we were asked to label this image Y. Okay, job done. I'm going to change color for the next question. Let's go with green. So part D now. So we've done that one. So part D, label or translate shape Y using the column vector 1, minus 6. We need to label this image X. Okay, so let's get rid of this last one here. So if the column vector for this one is 1, minus 6, the first number, because it's positive 1, is telling us to go right 1. And because the bottom number's negative, it's telling us to go down 6. Okay, remember negative is down. Okay, so down 6. So we're translating Y now. This is the new shape we've drawn. Okay, so I'm going to need to translate this shape right 1 and down 6. Okay, so I'm going to focus on this bottom right corner. Okay, so I'm going to go right 1, put a little cross there to hold my place, and then I'm going to go down 6. 1, 2, 3, 4, 5, 6. Okay. Now from this point, this is the bottom right corner of the triangle. Sorry. If I want to draw the top point of the triangle, I need to go up 3. So 1, 2, 3. If I want to draw the bottom left corner, I need to go across 2. 1, 2. And I just color it in, draw the triangle. Boom, nailed it. And this label, we're being asked to label it image X. Okay. So we've done that, job done. And there's one more to do now. So let's pick one more color. Let's go with lucky orange. So now we need to translate shape A using the vector minus 1, 4. We need to label this image D. Okay, so let's get rid of all this. So for this one, the column vector is minus 1, 4. So because the top number is minus 1, and it's because it's a negative, it means to go to the left 1 unit. Okay, and because it's positive 4, it's telling us to go up 4 times. Okay, and we're doing this on shape A, remember? So this is the original rectangle we were dealing with at the start. So I'm going to focus on the bottom left corner, okay? So I need to go left once. Boom, gone left once there. Then I need to go up 4 times. So 1, 2, 3, 4. So this is the bottom left corner of my new shape now. To get to the bottom right corner, I need to go 2 units across. So 1, 2. That's my bottom right corner. To get to the top right corner, you need to go up 3 units. 1, 2, 3. To get to the top left, 2 units across. Okay, so there we go. I've now translated this shape left 1 and 4 up. Okay, and we need to label this image D. Okay, and there you go. Those are the translation questions with column vectors. Okay, let's have a look at the next topic. Reflections. So for these questions, you'll be given a shape and you'll also be given a line of which to reflect that shape in. Okay, it's very similar to the translation shapes, and the shape will still look the same, but when we translate it, you just need to be careful where you move each point, okay? So because sometimes it's not as easy as just counting, looking at the original shape, okay? So for A, if I'm going to start with this top right corner, how many units is this point away from the line of reflection? Well, it's only 1 unit away. So that means on the reflected side, it's only going to be 1 unit away, okay? If I then look at the bottom right corner, how many units away is it from the line of reflection? Well, it's only 1 away. So that means I need to move 1 unit over the line as well, okay? What about the bottom left corner? Well, that is 1, 2, 3 units away now, okay? So that means I have to move 3 units in the other way from the reflection line, okay? So start from the line of reflection, 1, 2, 3. There you go. And then for the top right corner, again, it's 3 units away from the line of reflection. So that means I need to go another 3 units away from the line of reflection. Okay, and if I join up all these dots by here, then we have successfully reflected the rectangle in the mirror line. Okay, so you need to count how many units away each point is from the mirror line and continue that on the other side of the mirror line. Okay. Part B, again, reflect the rectangle in the given mirror line. So top left, we are 1 unit away. So we're going to go 1 unit on the other side. This corner, we are 1 unit away. So we're going to go 1 unit again on the other side of the line. This bottom right corner, we are 3 units away. You can count them, 1, 2, 3 units. So we need to go 3 units away from the line again. And the same story for the bottom left, because we're 3 units away, we need to count 3 units away on the other side of the reflection line, like so, okay? And join up the dots. You'd use a ruler for this, you wouldn't do it freehand, okay? Here we go. And there's our reflected shape, okay? So question C, now this is why we have to be careful when we reflect our shapes. We can't just draw the shape counting how far away each of the points are, okay? So you have to remember to do each point individually, okay? Because this is a really good example of why you need to be careful of that, okay? So for C, let's start with this point that's on the mirror line, okay? Well, because it's touching the mirror line, it's not going to be reflected at all. So we've actually drawn our first point of this rectangle, okay? Next, I'm going to look at this corner here. Now I can see it's almost half a square. So it's going diagonally across half a unit, okay? So that means to reflect this, I need to go away from the mirror line diagonally half a unit, okay? So there's my first point there. My second point, sorry. Now just look at the bottom left corner. How can I get straight to the mirror line? Well, you can see here, actually, if we go diagonally through 1.5 units, okay? We can see we go all the way through 1 unit diagonally, and then we stop halfway through the other, okay? So we need to go through 1.5 units diagonally on the other side of the reflection line, okay? So this is our first half, and then this is the rest of the unit, okay? So this is the reflected point from that one we've just looked at, the bottom left corner of the shape, okay? And then last but not least, we've got this top right corner. If we draw a line to the reflection line, I can see that it goes through 2 units diagonally. That means going away from the reflection line, I also have to go 2 units away from the reflection line, and that point will take me there, okay? Then if I draw my lines up to connect my rectangle, I have successfully reflected the rectangle in the mirror line, okay? So especially these diagonal lines can be very complicated very quickly, okay? So just take your time and be careful. Let's have a look at the next topic. Okay, so here's question 3 now. So we're looking at part A, and we're being asked to enlarge this shape by a scale factor of 2, okay? So a scale factor basically tells us how much bigger we're making a shape, okay? But if it's a fraction, it would get smaller. So we're going to have a look at those questions later on. But for now, we just want to enlarge this shape by a scale factor of 2, okay? And all that means is whatever the sides of this shape are, we need to multiply all those numbers by 2 to get our new shape, okay? So if we've got our original shape, all we're doing is we're multiplying each side by 2, okay? So for example, if we look at the shape now, it's got a base of 2, it's got a height of 4, it's got 1 unit at the top, 1 unit on the side there, and another 1 unit going across there. Then it's 3 units going down, okay? So when we enlarge this shape by a scale factor of 2, we're basically going to multiply all these numbers by 2, okay? So again, we'll start at the bottom. So 2 times 2 is 4, 4 times 2 is 8, 1 times 2 is 2, 1 times 2 is 2, 1 times 2 is 2, and 3 times 2 is 6, okay? So this is the new shape we need to draw now, okay? So let's just pick a point on our graph paper. So this is the bottom left corner of my shape now, okay? So my new shape has a base of 4 units, so I need to go across 4 units. It then has a height of 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. Perfect. It then goes to the left 2 units, 1, 2, and then goes down another 2 units, 1, 2. To the left 2 units, 1, 2. And then it finally goes down 6 units, 1, 2, 3, 4, 5, 6. Okay. So we have now increased this original shape by a scale factor of 2. Okay. So scale factor of 2. So we've made all the sides of the shape 2 times bigger. Okay. And if there was a scale factor of 3, you'd multiply all the sides by 3. And if scale factor of 4, you multiply them all by 4. Okay. Let's have a look at part B now. So we're asked to enlarge shape A by using a scale factor of 2 using 0, 0 as the center of enlargement. Okay. So this coordinates, there's 2 bits of information here. We're looking to enlarge by a scale factor of 2, and we're using the coordinate 0, 0, or the origin of a graph, as our center of enlargement. Okay. Now, as it happens, each side will get bigger by 2 units. Okay. But when we enlarge about a point, the position, we're also being told where the shape will end up. Okay. So first things first, we need to find out, so for B here, we need to look at how far it is to get from 0, 0 to this bottom left corner of the triangle. Okay. So if you count across, you go 1, 2, 3, 4, 5. So it's 5 to the right. So 5 to the right and 1, 2 up. Okay. And then 2 up. Okay. So if we do a scale factor of 2, we need to multiply these instructions by 2. Okay. So instead of going 5 across, we're going to go 10 across. And instead of going 2 up, we're going to go 4 up. Okay. So let's do that. So we're starting at the origin, starting at 0, 0, and we're going to go 10 across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put a little cross there. And instead of going 2 up, we're going to go 4 up. 1, 2, 3, 4. Okay. So let's write BL. So BL for bottom left. Okay. Now let's do bottom right. So BR. Okay. How do we get to the bottom right from 0, 0? Well, we go 1, 2, 3, 4, 5, 6, 7 across. And we go 2 up. Okay. Now again, because there's a scale factor of 2, we need to multiply all these instructions by 2. So instead of going 7 across, we're going to go 14 across to the right. And instead of going 2 up, we're going to go 4 up. Okay. So let's do that quickly. So starting at 0, 0, we're going to count across 14, put a little cross there. And then we're going to go up 4. 1, 2, 3, 4. Okay. So now we've got the base of our triangle here now. Now let's do the final top right corner of this shape. Okay. How do I get to the top right corner? Well, it looks like I have to go 7 across. And I have to go 1, 2, 3, 4, 5 up. Okay. If I increase this by a scale factor of 2, instead of going 7 across, I'm going to go 14 across. Instead of going 5 up, I'm going to go 10 up. Okay, so let's do that. So start at 0, 0, go across 14, and then we're going to go up 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my final point, and then I can just connect the dots to make my new enlarged triangle. Okay, I'm going to call this shape B. All right, job done. Now for part C, now we're enlarging the shape A by a scale factor of 1/2. Okay, so all that means is instead of multiplying everything by 2, we're going to be multiplying everything by 1/2. Okay, so we're going to be halving everything, but we're also going to be using the coordinate 1, 4 as our center of enlargement. Okay, so the coordinate 1, 4. Remember, the first number is the x-axis, the second number is the y-axis. Okay, so 1, 4 would be 1 across and 4 up. So tell you what, let's do this in a different color pen. do this in blue, okay? So we're doing C in blue now, okay? And we're enlarging shape A by a scale factor of a half, okay? So everything's going to be half the size as it was originally, okay? So let's do the bottom left corner again, okay? Ooh, hello. So let's do bottom left, okay? How do I get to the bottom left corner from this new coordinate, okay? Well, I go 2 down. So I go 2 down. And I go 1, 2, 3, 4 to the right. Okay? Now the scale factor this time is a half. So I need to multiply everything by a half, okay? And just half the number. So that means instead of going 2 down, I'm going to go 1 down. Instead of going 4 to the right, I'm only going to go 2 to the right, okay? So starting at this coordinate 1, 4, I'm going to go 1 unit down to there, and then I'm going to go 2 to the right, 1, 2. So that blue dot is my new bottom left part of the triangle, okay? Let's now do the bottom right part of the triangle. So how do I get to the bottom right? Well, I go 2 down again, 2 down, and I go 1, 2, 3, 4, 5, 6 to the right, okay? Again, I'm going to multiply this by a half. Half of 2 down is going to be 1 down, and half of 6 to the right is going to be 3 to the right, okay? So to draw the bottom right corner, starting at my 1, 4 coordinate, I'm going to go 1 down, same as that, and then I'm going to go 3 to the right, 1, 2, 3. And there we go, job done. So that's the bottom right corner done. Now I need to find the top right corner of this shape, okay? So now we're doing the top right corner, okay? How do I get to this point from our starting coordinate? Well, I have to go 1 up. So let's mark it there, 1 up. And I have to go 1, 2, 3, 4, 5, 6 to the right, okay? Now I have to times these by a half. So 1 half of 1 is a half. So I have to go half a unit up. And half of 6 is 3 and is going to the right, okay? So for this final coordinate now, I need to go half a unit up, which is going to be halfway in there. And then I need to go 3 units across like this, connect the dots, and I'm asked to label this image C, okay? So we've now got a shape that's half the size of shape A, okay? So we've enlarged it by a half, okay? So same as making it smaller. Let's have a look at the next question now. So Pythagoras' theorem. So these first 2 questions are on finding the long side, okay? You should all remember by now, Pythagoras is a squared plus b squared equals c squared. If we have a right angle triangle and the 2 shorter sides are a and b, and the long diagonal side called the hypotenuse is c, okay? So let's have a go at answering these questions. So first of all, I know we've called this hypotenuse side A, but we're going to label them as A, B, and C as we normally do, okay? So I'm going to call this A, B, and C for the hypotenuse, okay? And we know that A squared plus B squared is equal to C squared, okay? So A is 6, so 6 squared, plus B is 8, so 6 squared plus 8 squared is equal to missing side A squared, okay? If we just continue this again, 6 squared is 36, 8 squared is 64, and if we add 36 and 64 together, we get A squared. So we end up with 100 is equal to A squared. Okay, sorry, let's change that around. A squared is equal to 100 because 36 plus 64 is 100. Therefore, A equals the square root of 100. Therefore, A is equal to 10 centimeters. Okay, that's how we've used Pythagoras to find the short side, or the long side of a triangle, sorry. So for part B, We're given two sides and we're not given the long side again. So we're going to label up the triangle again quickly. So we've got A, B, and C. So just like always, A squared plus B squared is equal to C squared. A is 7. So 7 squared plus B is 6. So 7 squared plus 6 squared is equal to, in this case, C is B, equal to B squared. 7 squared is 49. 6 squared is 36. And this is going to be equal to B squared, okay? So B squared is equal to 49 plus 36 is 85. Therefore, B is equal to the square root of 85, okay? Now, I highly doubt you know this without a calculator, but if you were to get a calculator, you typed in the square root of 85 to 2 decimal places, which is what the question asks you for, you would find that it is 9.22 meters, okay? So those questions we found the long side of a triangle, okay? And the next two, we're going to find the short, one of the short sides, okay? So here we go. Part C and D now. So we need to find the missing side with, let's go the letter on it. And we need to round our answers to 2 decimal places, okay? So we're given here, let's label up these sides. So we've got A, B, and C. So here we go again. A squared plus B squared equals C squared. A is C, so we don't know what that is, plus B is 27.5 squared, and those added together will give you 30 squared, okay? And if you solved 27.5 squared and 30 squared, you would find that C squared plus 756.5 is equal to 900, okay? So therefore, in order to something plus 756.5 equals 900, okay? So we need to find the difference between 756.5 and 900. So we'll take the small away from the big. So C squared is equal to 900, take away 756.5. Therefore, C squared is equal to 143.75. Therefore, C is equal to the square root of 143.75. And again, I doubt you know this off the top of your head. If you used a calculator, you would find that C is equal to 11.99 kilometers. So very well done if you got that right. Okay. So next part now, we're given a triangle where we're told both sides are 20 meters and the bottom side is 30 meters. Okay, well, actually, what we're looking at here is an isosceles triangle, okay, because these two sides are the same length. That must mean that we can actually make another right angle triangle within this triangle, okay? So have a quick think. What do you think the length of this side, this bottom side of this triangle would be, okay? So actually, it would be 15 meters, okay? Because if the whole base of the whole triangle is 30 meters, and it's an isosceles, and we're doing halfway down the middle, that means we're only working with half of the triangle, okay? So what we've got is a right angle triangle where we know one of the sides, let's call this A, is 15 meters. We don't know what side D is, we're going to call that B, and the hypotenuse is 20 meters, okay? So, as always, A squared plus B squared equals C squared. A squared is 15 squared. We don't know what B is, but we're told it's D, so let's write down D squared. So 15 squared plus D squared equals 20 squared. Okay, let's just solve these. So 15 squared is 225. So 225 plus D squared is equal to 20 squared, which is 400. Okay. So 225 plus something is 400. Okay. So d squared is equal to 400. Take away 225. D squared is equal to 175, therefore. And that must mean that D is equal to the square root of 175. And again, I highly doubt you knew this if you didn't have a calculator. If you found the square root of 175, you would have got 13.23 meters for your final answer. Okay, so very well done if you got that as well. Let's have a look at the next question now. So part E, does the following triangle contain a right angle? You must show how you decide. Okay, so what we're trying to find is this, it's probably going to be this corner because there's the two shorter sides. Is this a right angle triangle? Okay. Well, if this was a right angle triangle, then if 7 was A, 10 was B, and 12 is C, they would conform to A squared plus B squared equals C squared, because this only works with right angle triangles. Okay. So let's try it out. So we've got A squared plus B squared equals, oops, not C, 7 squared. A is 7, so 7 squared plus B is 10 equal to 12 squared. 7 squared is 49, 10 squared is 100, and 12 squared is 144. So 49 plus 100, does it equal 144? 49 plus 100 is 149, which does not equal 144. Okay, so therefore not a right angle triangle. Okay, so because A squared plus B squared didn't equal C squared, we can confirm that this is not a right angled triangle. Okay, so that's how you would prove if a triangle is or isn't right angled. Okay, so next question now. Volume of a prism. Okay, so we've got two prisms here. We need to find the volume of these shapes. Okay, so the formula, so volume of a prism is the cross-sectional area multiplied by the depth of the shape. Okay, so for example, if we look at the first question, question A, let's put that in a little box. The cross-sectional area is this area. Okay, and then the depth would be the 3 centimeters. Okay, so for A, so I'm just going to call it the cross area. Okay, so how do I find the cross area of this shape? Well, the two sides of this shape are 6 centimeters and 4 centimeters. So therefore 6 centimeters times 4 centimeters, that will give me 24 centimeters squared. Okay, so that's the cross-sectional area of the shape. Therefore, sorry about that. Therefore, volume is going to equal 24 centimeters squared multiplied by 3 centimeters. Okay, so 24 centimeters squared times 3 centimeters, that will give you 72 centimeters cubed. Okay, because when we're dealing with volumes, it has to be centimeters cubed. Okay, let's jump into question B now. So let's get rid of this box, sorry, so we see all the distances. So first of all, we need to find the cross-sectional area. Okay, so let's find the cross area. And this, remember this, so what we've got is a triangle here. Okay, so actually the formula for this is going to be half times 6 centimeters times 7 centimeters. Okay, 6 times 7 is 42, so we're going to do a half times 42 centimeters squared. A half times 42 equals 21 centimeters squared. Okay, so this is our cross-sectional area. Therefore, the final step, volume equals the cross-sectional area, which is 21 centimeters squared, times by the depth, which in this case is 9 centimeters. Okay, then if you use a calculator, 21 times 9, you should get 199. Oh, no, sorry, 189. Sorry. 189 centimeters cubed. Okay, so that's how you find the volume of prisms. Okay, so one more topic. We're going to find the volume of cylinders now. Okay, so let's have a look. So we've got two cylinders here. Okay, and we need to calculate each of the following. So again, it's going to be exactly the same thing. It's the volume equals cross-sectional area multiplied by depth. Okay, but in this case, the cross-sectional area is going to be the circle. Okay, so we have to remember the formula for the area of a circle. Okay, and the formula for the area of a circle, so area of circle is equal to pi r squared. Okay, so we're going to be using both of these formulas to answer these two questions. Okay, so first of all, let's find, for question A, let's find area of circle. Okay, let's do this now. So we need pi, which we're going to take pi to be 3.14. Okay, if you were using a calculator, you could use the pi button. But if you weren't using a calculator, use 3.14. But I'm just going to use 3.14 in the calculator. Okay, so area of circle. So pi r squared. Pi is 3.14, so 3.14 times, in this case, the radius is 5, so times 5 squared, which is 3.14 times 25. And if you type that into a calculator, you should get 78.5 centimeters squared. Okay, so this is the area of our circle. Okay. And then finally, volume is going to be 78.5 centimeters squared times by the depth, which is 12 centimeters. Okay, and if you type that into your calculator, you should get 942 centimeters cubed. Okay, so that's the final answer for the volume of the first cylinder. Now for question B now, let's find the area of circle, or the cross-sectional area. And that's going to be equal to pi r squared. So that is equal to 3.14 times, now we haven't got the radius of the circle, we've got the diameter, which is 16. Okay, so the radius is half of that. So the radius is 8. So 3.14 times 8 squared. 3.14 times 64. And if you type that into your calculator, sorry, 2 seconds, you should get times 64, 200.96 centimeters squared. So that's the area of our circle. Okay, and the final volume is 200.96 centimeters squared. Multiply that by the depth, which is 4.5 centimeters, and that will give you an answer of 904.32 centimeters cubed. Okay, so if you know how to do that question, very well done. Okay, it's a lot to do in these questions. Okay, so moving on to the next question now.
Right, then question 7 is on surface area of a prism. Remember, surface area, just means the area of all the surfaces on a shape. So if we do shape A, then remember, this is a cuboid, okay? And a cuboid's got 6 faces. Sorry about that. And they're all rectangles. Remember, you've got the front, which is here, okay? And that's a rectangle. So it's length times width. So that's 28 meters squares. Now the back, remember, which you can't see, but it's obvious it's the same size as the front, so it's got the same area. I'll do the top next now, okay, the top side, which is here. So here's the top, I'll do it in blue. Can we see that the top's also a rectangle, and it's 7 long and 2 wide, so 7 meters times 2 meters, that's 40 meter squares, and the bottom, again, is obviously going to be the same as the top because it's a cuboid, and then all that's left then is, should I do it in purple maybe? Yeah, at the sides, okay, so I call that the right hand side. It's a rectangle again, and it's 2 by 4. So 2 meters times 4 meters, that's 8 meters squares, and the left is the same. Remember the final step now for the surface area is to just add all these up, find the total. So the surface area is 28 at 14, at 14, at 28, you get the whole point. Add them all together, okay? So 28 at 28 at 14 at 14 at 8 at 8 gives me a lovely 100 meter squares. Job done, easy. And the shape B now, remember this is a triangular prism, so it hasn't got 6 faces, it's only got 5 faces. Remember, I got the front first of all. Now it's a triangle. Remember, a triangle's area is the base times the vertical height divided by 2. 7 6 is 42, half 42 is 21 meters squares, and the back, again, you can't see the back, but I hope you agree. It would, if I draw it like a wireframe, see the back would be the same as the front, definitely. Okay, that's also 21 meters squares. Right, now I'll do the top now. Okay, all right. So here's the top, this blue one here. Okay, so the top is definitely a rectangle again, and it's 9 by 10. Okay, no half in this one, it's a rectangle. That's 90 cm squared. So I just realized I made a small mistake, haven't I? These will be in cm squares. You're not meters. I'm sorry about that, because the whole thing is centimeters. Now the bottom is not the same as the top in this case, all right? Because the bottom, if I go over in green, the bottom, here's the bottom of the shape here. Here is the bottom, and it's not the same shape as the top, all right? But it's still a rectangle, and this one is 9 centimeters. See, 9 by 7. And 9 times 7 is 63 cm squares. And all that's left then, if you pardon the awful pun, is the left-hand side. So here's the left. If I go over the left in purple, see, here is the left-hand side here. If I try and shade it all in. Okay, sorry, just up to here is the left-hand side. See, it's a rectangle again, and it's 9 long and 6 high. So 9 times 6 is 54 centimeter squares. But the final step here for the surface area is always to add together all the faces. So the surface area, you have to add all these together. So I got 20, 21, 21, 90, 63, 54, gives me 249 centimeter squares. Job done. And this last one now, this cylinder is the most complicated of all because, well, if you watch the lesson on this, you'll know it's a bit more involved. Because how many surfaces has this cylinder got? Well, only 2. 3 surfaces, right? Because if you broke it apart into a net, it's going to have a circle on the top, remember, and a circle on the bottom, and they're going to be connected by a rectangle that wraps around these 2 circles, remember, to make the actual body of the cylinder. That is the shape you're looking at if you pulled it apart. Okay, remember this is the top face, this is the bottom, and this is the body here, okay? I'll add some measurements to this. Now, obviously, across the top, we can see that's going to be 16 centimeters. And for the bottom as well. And the body is 4.5 centimeters, how you can see it here, all right? So let's do the top and bottom first, because the top and bottom are easy because they're just circles, okay? So the top is a circle. Remember, a circle's area is pi times radius squared, okay? And remember now that the radius of a circle, remember, is not all the way across, it's half the way across. So half of 16 is 8. So I have to do pi times 8 squared. Okay, now you could use, remember, you could do, couldn't you? Remember, pi is 3.14. So you could do 3.14 times 8 squared. I'm going to use a calculator. Here, look. All right. I'm just going to do pi times 8 squared. And you get 201.06 centimeters squared. That's 2dp. If you use 3.14 for pi, then you will get a slightly different answer, okay? Now the bottom, you can tell, can't you? The bottom is obviously the same shape as the top. So it's going to have the exact same area. 201.06 cm squared to 2dp. All right, and now the body is the hardest part now. Because the body is obviously a rectangle. So I know it's going to be something times 4.5, you see, because it's 4.5 high, definitely 4.5. The tricky part now is how long is that length there. And we showed them in lessons, this yellow length here has to wrap exactly around the circle to make the perfect cylinder. And so it has to be the same length as the distance around the circle. Remember though, that's called the circle's circumference. So this here, okay, this needs to be the circumference of the circle. Remember, a circle circumference is pi times diameter. So this would be pi times 16, because this diameter here is 16. Okay, again, I use my calculator. If I do pi times 16, I get 50.27, 2 decimal places. 50.27 centimeters to 2dp. So now the body is 50.27 times 4.5 and 50.27 times 4.5 is 226.22 cm squares to 2dp. The last step, remember, is just add them all together to find the total surface area. So there's only 3 faces here. So add these up. Okay, so 201.06 plus 201.06 plus 226.22 gives me 628.34 cm squares. All right, and the cylinder is definitely the hardest one to do. So if you can cope with a cylinder, you can cope with any of these. So that's all done. Next question, please. Okay, question 8 then. Similar shapes. Remember now that 2 shapes are similar if one shape is an enlargement of the other one. So with similar shapes, okay, all you care about is the scale factor. All right, so it tells us these shapes are similar. I want to find these in lengths here. I've got to find y and x. Okay, well, if you look at this shape here, so it says this right-hand shape is apparently an enlargement of this shape. So I want to find the scale factor. So if you pick 2 matching sides, see these 2 sides here? Oh, maybe yeah. See these 2 sides match up here. All right. So I'm trying to think now, and basically how many times bigger I've made 10 to get to 25. So if you do 25 divided by 10, you get that this has been multiplied by 2.5. Okay. So for this one, okay, the this is called the length scale factor, is 2.5. So that means now, right, if I look at, perhaps try to find y, see that 8 and y are corresponding sides. So I know now, all right, that to get this one here, I'm just doing 8 times 2.5. You see? So y is going to be 8 times 2.5 centimeters, which is 20 centimeters. Okay, so I found y. And now if I want to find x, see if I want to find x, it matches up to this side here. But this time round, because I'm going from 50, obviously x is smaller than 15. So going from this direction, I am timesing by 2.5. If I'm going to go backwards, I would have to divide by 2.5. Okay, so x is going to be 15 divided by 2.5, which is 6 centimeters. That is really easy. All right, and that question is done. Next one then, speed, distance, and time. Remember, the only thing you have to remember here is the formula. Remember, speed equals distance divided by time. Okay, so question A, what do we know then? So look at the average speed of a man. So he walks 20 kilometers in 4 hours. So the distance is 20 kilometers. And the time taken is 4 hours. So remember, speed is distance divided by time. So it's 20 kilometers over 4 hours. And 20 divided by 4 is 5. It's going to be 5 kilometers per hour, you see, because I got kilometers on top and hours on the bottom. And that's what I wanted. Job done. And then part B, more of the same. See, the distance, again, is 3,480 miles. And the time taken is 5 hours. So now speed is distance divided by time. So it's 3,480 miles over 5 hours. Okay, and if you do 3,480 divided by 5, you get 696 miles per hour. Okay, now miles per hour is so common, it's got its own abbreviation. It's written as mph. Very easy topic, job done. Next question, please. Right, density. Remember density? The formula is density equals the mass divided by the volume. That's all there is to it, okay? So this parcel is in the shape of a cuboid. I see it. The parcel weighs 4 kilograms. So this whole thing weighs 4 kilograms. The dimensions are given below. I see that. Find the density of the parcel. Give your answer in grams per cm cubed. Right, well, the first thing I spot here now, all right, well, let me write the formula down. Density, okay, is mass over volume. So at the moment, what do I know? All right, well, I know the mass is 4 kilograms, all right, but I can't put 4 kilograms on top of the fraction because it's asking my answer in grams per cm cubed. See, that means I need grams on top of this fraction. We should know, shouldn't we, that 4 kilograms is 4,000 grams, okay, because 1 kilogram is 1,000 grams. So this is going to be 4,000 grams on top here. And at the moment, what is the volume? I don't know, all right, but we know, don't we? Remember, a cuboid's volume is just the length times the width times the height. So it's going to be 40 centimeters times 12 centimeters times 20 centimeters. Okay, And 40 times 12 times 20 is a rather large number. It is 9,600 cm cubes. Okay, remember volumes in cubes and the measurements in centimeters. So this is 4,000 grams divided by 9,600 cm cubes. Look, see, and I got my units now, so I'm good to go. So if you do 4,000 divided by your volume, you actually get not a very pleasant answer, but to 2dp, I got 0.42 grams per cm cubes to 2 decimal places. Okay, job done. I think the last one then, population density. Again, if you know the formula, it's easy. Remember, population density of a region is how crowded it is, but the formula is population divided by the area of the land. Okay, so this one's easy because I'm told the population is 154,000 people. I'm told the area is 220 kilometers squares. So my population density is the population over the area. So 154,123 divided by 220 gives me a lovely answer of 700. The units will be people per kilometer square. Easy topic, job done.